You know, deep learning is one of those technologies that is just completely shaping our world. But how do you actually go from being kind of curious about it to becoming a real expert? Well, it turns out MIT has laid out the entire path, and they've made it available to absolutely everyone. So today, we're not just looking at some course syllabus. We are deconstructing a complete blueprint for mastering AI.
So, what does it really take? What's the secret sauce they're cooking up inside a top-tier university like that? Well, thanks to MIT's OpenCourseWare, we actually get to pull back the curtain and see the exact structure, the exact game plan they use to build world-class AI talent. Okay, let's dive right in.
The journey starts exactly where it should, with the absolute fundamentals. You might think it starts with some super dense, abstract theory, right? But nope. MIT's approach, from the very first lectures, is all about getting your hands dirty and really understanding the core mechanics of how this stuff actually works.
Now, what's so cool about this is how quickly the course just demystifies what seems like a really complex process. I mean, in just the second lecture, they break down training a neural network into these 4 simple, totally understandable steps. You get your data, you define your model, you tell it how to measure its own mistakes, that's the loss function, and then you just let it learn and get better. See? It's a practical, repeatable process, not some kind of magic.
And this quote right here, this pretty much sums up the entire philosophy of the course. A whole lecture is actually dedicated to what they call the Hacker's Guide to Deep Learning. The message couldn't be clearer. Theory is crucial, of course, but true understanding, that comes from building things, from experimenting, and from seeing what works with your own 2 eyes. It's a very hands-on, roll-up-your-sleeves kind of approach.
So, once you've got that solid foundation, it's time to start building your toolkit. Because deep learning isn't a one-size-fits-all kind of deal. Not at all. Different problems need different types of neural networks or architectures. And the course just systematically introduces you to the major ones, kind of like a master craftsman showing you all the specialized tools of the trade.
Let's just quickly look at the main tools in the kit here. If you're working with images and pixel data, the course introduces you to architectures built for grids, like the famous convolutional neural networks, or CNNs. Then, if your data is all about relationships, think social networks or protein interactions, you get to learn all about graph neural networks. And for language and text, you master transformers, which are absolutely brilliant at understanding sequence and context. Each lecture is basically handing you a powerful new tool for your kit.
And the toolkit doesn't even stop there. The curriculum then dives into even more advanced architectures, like ones that can give a model a form of, well, memory. And this is so crucial for tasks that require remembering information over long sequences, really pushing the boundaries of what these systems can actually do. Okay, so you've learned the how and the what. Now comes the most important part, really the why. This is what separates someone who can just follow instructions from a true innovator. And that's why MIT dedicates a huge chunk of the course to building a deep, intuitive understanding of the theory that makes all of this possible. So the whole thing really boils down to this one crucial concept: generalization. As Lecture 6 explains, it is the ultimate goal. You don't want a model that's just memorized the answers to the test questions. No, you want one that can ace a brand new test it has never ever seen before. This right here, this is the holy grail of machine learning. And think about it this way, right? When you study for an exam, just memorizing specific questions and answers is, well, it's a terrible strategy. The second a new question comes up, you're totally stuck. The exact same thing is true for AI models. Rote memorization is basically a failure.
Right. Genuine learning, for us humans and for machines, is all about understanding the underlying principles, the actual rules of the game. And that is why the course dives so deep into concepts like approximation theory and representation learning. It's all about teaching the model how to think, not just what to remember.
And this just gives you a taste of the depth of that theoretical core. I mean, we're talking about the mathematics of how models learn, why they generalize, how they get better with more data and more computing power. These are called scaling laws, and how they form useful representations of the world. This is the stuff that powers real breakthroughs. And here is the payoff. This is it. All that foundational practice, all that deep theory, it all leads to this, the incredible, almost magical capabilities of modern AI that we see in the headlines every single day. The course makes sure you understand exactly how these amazing systems are actually built.
This is where it all comes together. The lectures on generative and language models show you how to build systems that can actually create. They can generate art, they can write compelling text, and they can communicate with us in natural language. This isn't science fiction anymore. It's the direct application of all those principles we just talked about.
But
You know, building a great model in the lab is only half the battle. The final and maybe the most critical stage of this whole educational journey is about making AI work reliably and efficiently out in the messy, unpredictable real world.
This slide makes a really important distinction. See, in the lab, your data is what's called in distribution. It's clean, it's predictable, it looks a lot like what the model trained on. But the real world? The real world is out of distribution. It throws curveballs, it's messy and unexpected. A self-driving car has to handle a weird shadow it's never seen before. Lecture 17 tackles this massive challenge head-on.
So to succeed out there, in the wild, you need a new set of advanced skills. The curriculum teaches you how to adapt models that already exist to totally new tasks. That's a powerful technique called transfer learning. It also covers how to make models run super quickly and efficiently on real hardware. These are the practical skills that turn a cool prototype into a real product.
So that's the blueprint, a complete, structured path that takes you from the very first principles through building a professional toolkit to understanding the deep theory and finally to creating amazing applications and actually deploying them in the real world.
And here's maybe the most amazing part of all this. Right now, there are over 23 lectures from this exact course available for anyone to watch, for free. A world-class education just out there, accessible to anyone who wants it.
So just remember, what we've walked through today isn't just some random collection of topics. It's a carefully designed curriculum. It's a coherent roadmap where every single piece builds on the last one, all designed to take you from the beginning all the way to mastery. MIT has given us the blueprint for understanding and building the future. The only real question left is, what will you build with it?